Okay, let's do another paper. Let's do it. Let's do it. Just do it. We'll be doing a mechanics. The most recent one I could find is a 2025 mechanics paper. Funny enough, I've actually been doing a lot of high-level mechanics recently, trying to prove one of my crazy physical theories of the universe. So I've been doing a lot of mechanics, so this should be pretty straightforward for me. But I've got the answers on my other screen, the marked screen, so I can check my answers as I'm going, and we'll just crack right into it. How's everyone doing? Everyone good? We good? Huh? Tell me. All right, let's just crack right into it. Well, my name is Jacob, so I might as well put that down. And let's go. Okay, we'll just start running through this. Okay, again, I have the exam hack course on mechanics on my YouTube channel. So you should go through that before you attempt these past papers. And like I said in the previous video on Pure 1, this is what you should be doing as the exam comes closer. You should be doing timed, controlled, exam-controlled conditions and doing a test like this. I would recommend checking the answers at the end, but because I haven't looked at this, I would check them as I go to make sure and ensure I'm doing them correct. Can't be doing all of them wrong. Be no good, no help to anyone. Okay, anyway. Three coplanar forces of magnitude 40, 30, and x acting at a point in all directions shown in the drawing. Given the forces are at equilibrium or inequilibrium, find the values of theta and 0. Okay, well, I have a whole video on this. Okay, if they're at equilibrium, that means that all the x components of these forces will equal 0, and all the y components of these forces will equal 0. So you could write it in a fancy way. You could do the sum of these x components and y components will equal 0 in vector form. So we just have to find out what those x components and y components are. We have this thing here, which has an x and y. So the x will be, so this is opposite adjacent. So this x component and y component here will be opposite adjacent. So cos theta equals x over x. So x equals x cos theta. And here that means that y will equal x sine theta. Okay, I'm just jotting that down before I begin. Okay, so in the x direction, what do we have? We have, well, this 30 just acts exactly up. So we have this x component positively, so x cos, so we can say x direction, x cos theta plus, well, minus 40 will equal 0. Right? Because it's acting that direction positively and it's acting negatively. So we can say x cos theta equals 40. And that's one equation we will need. And in the y direction, we get, well, there's no y component of the 40, so we get 30 minus a y component, which is sine theta. X sine theta 0. So we get x sine theta equals 30. That's another equation we're interested in. My cat's pretty loud. I wonder if you guys can hear that. Okay, so if we simply divide equation 1 and 2, we're going to get x sine theta over x cos theta equals to 30 over 40. You simplify that, the x's will cancel. Why is it going down? The x's will cancel, and you get sine theta over cos theta is tan theta, so you just get tan theta equals, this is 3 over 4. So therefore, theta equals to the inverse of tan of 3 over 4. So this is 36, so rounded is 36.9 degrees. So that's our theta. And our Therefore, our x, we can just substitute in one of these equations. So we substitute into 2. Let's say we get that sine theta of this, so sine of 36.9 degrees equals to 30 over, I guess you'd rearrange for x easier. So x equals 30 over sine theta, and theta is this. So you get 36.9. I'd keep it in this exact form, so don't round it. So it's actually 36.869, a lot large number, so you can get the exact value. So the sine of this, 30 divided by answer, is equals 50. Okay, so that's what that is. So 50, and so we'll go to the Mac screen and we'll check those answers. We'll be going for 100% here. Okay, so 36.9 and 50, cool. So tick, and that's 4 marks. Okay, so I just realized I was on my Mac screen. I forgot to switch back to the iPad. So I've got to remember to do that. Maybe I should stop like switching between them, maybe. I'm not used to working on the iPad. Okay, anyway. Okay, a cyclist is traveling along a straight horizontal road at speed 4 meters per second. When she passed the point O, she accelerates at a constant rate for a distance of 42 meters, reaching the speed v meters per second. Okay, I'm just gonna, like, they've got a lot of segments going on here. So I'm just gonna visualize briefly what's going on here. So she's traveling along a road for a distance we don't know, at 4 meters per second. So she's traveling at 4 meters per second, and this is the point O. When she passes the point O, she accelerates at a constant rate for 42 meters. So she accelerates 42 meters, and she's accelerating. We don't know what the acceleration is, but she's accelerating, reaching a speed v. So here she's moving at v meters per second. She maintains the speed v meters per second for 50 meters. So for 50 meters, she maintains the speed, so she'll still be at speed v here, meters per second. And then deaccelerates. She has a deacceleration of, so acceleration is minus 2 meters per second squared here, before coming to rest. So here she's moving at 0 meters per second. And she's deaccelerating at 16 meters. Okay, I just did that because there's a lot of segments going on here in the motion of this lady. And so we want to visualize what's going on, what we know, what we don't know. Okay, anyway, so find the value of v. Find the value of v. Okay, so what formulas do we have? Let's say, okay, so we've got, okay, so on your formula sheet, okay, I must remember to switch back. So Mac screen. On your formula sheet, you have these formulas, basically all they give you. And, okay, switch back to the iPad. Okay, so you're probably going to want to use, I'm just looking at this segment here. You're going to probably want to use this because we don't have the acceleration. So you're going to look for a formula in which you don't have the acceleration. You maybe could do this one, the 16 meters, but don't think that would work, would it? You got a deacceleration time. You got the initial, the final, you got the distance, and you got the deacceleration. So you actually could use that one. Okay, I'll use that one because it's easier. Okay, so for this final segment here, we have our initial is v, our final is 0, our acceleration is minus 2 meters per second squared because we're deaccelerating, and our distance traveled, displacement is 16 meters. And on your formula sheet, well, I mean, you have the formula v squared equals u squared plus 2af. Okay, so v squared in this case, so 0 squared equals v squared, this thing we're trying to find, plus 2 minus 2, 16. The reason I did that is because, well, I'm going to get a v here. I have all those things, I just don't have v. So we get v squared here equals what? 2 times 2 times 16, so 64. 64, so therefore v equals to 8 meters per second. Okay. So it looks easier when you split it up. You could have picked other things. So if you didn't know what to do there, you could try, okay, I'll pick this part here and see, oh, I couldn't find it. Pick that, oh, I can't find it. And then you notice that you have the most stuff that you kind of know there, and you can use one of those equations to find it. Anyway, find the total time for which she is in motion from the inch she passes. Oh. Okay, so what do we have here? So the total time from here to here. So we can split this up into 3 segments. I would do that. So T1, T2, and T3. So we calculate the time for each of these segments, sum them up, and we get the total time. So the total time will be T1 plus T2 plus T3. Okay, so let's find out each one individually. So T1, so what do we have in T1? So in T1, we have our initial, which will be 4 meters per second. So our initial is 4 meters per second. Our final is going to be V, which is 8 meters per second. Our acceleration, we don't know. We might need that. S equals 42 meters. And so we want to find the time. So the time we don't know. So T1. And you have an equation. If I go back to the Mac screen, you have this equation here. See, that's what happens. I click away and then I forget. Okay, so you have this equation here. So you go, so we have S equals a half of U plus VT. So I have this, I have that, I have that. So I can find T. So therefore we get 42 equals to a half of 4 plus 8 times T. So this gives us 12 divided by 2, so 12 divided by 6, and then 42 divided by 6 is 7. So for the first part, T1 is equal to 7 seconds. So that we will need. Then we do T2. So T2, the second part is this part here. So here we might need the acceleration. We have, oh, maybe not. No, this is just velocity over time. Okay, so we have the velocity is the same, and the 50. So we have, our initial is 8 meters per second. Our final is 8 meters per second, and our distance traveled is 42 meters. So we're moving at a constant velocity, so this is just distance over time. So, velocity equals distance over time. So time equals distance over velocity. So the time here, T2, will equal to our distance, which is 42, over our velocity, which is 8. 42 divided by 8. This is 5.25 seconds. Okay, we will be needing that too. And finally, don't give us enough space, of course, our T3. T3 will, this will be able to. So we have these things for our T3. So this is 8, 0. So we can use pretty much anything here. What's the easiest one to use? Use the same thing, V squared plus U squared. No, VU plus AT. So we can use that V, it's on your formula, so U plus AT. So we get from this part here, our V initial is 8. So this is going to be 8 equals our final is 0 plus minus 2 is our acceleration T3. It's our T3. So we just get, does that make sense? That shouldn't be a negative. V final 0, acceleration U initial. Sorry. No. Our U initial is V. Sorry, I did that wrong. See, I noticed we shouldn't get a negative time. That doesn't make sense. So it's like this. Okay, and then you're going to get T3 equals to second. So your total time is the sum of all these things. So 4 plus 5.25 plus 7 is 5.25 plus 7 plus 4. 16.25. Okay. Have I done something wrong here? 16.25 seconds. Let's check that. 17.25. Felt like that was wrong. Why did I feel like that was wrong? What have I done wrong here? T equals 7, T equals 4. This is 6.42. 42 divided by 8. 42 divided by 8. 50. Oh, there we go. That's what I did wrong. Okay, so I check that back. It's fine. You know, I get things wrong. I do mistakes. I'm human. I just didn't do, this is 50 meters. 50. So that'd be 6.25. So a small mistake. And maybe, okay, if I'm being honest, I mean, I would have probably lost a mark there. So that probably would have been 2 marks. It's okay. And the next one is 8. So iPad, okay. 2. Okay. So we did lose 1 mark. It's all right. Okay, let's keep going. An airplane is flying at a constant speed. The airplane is flying horizontally. The airplane's engines are producing a constant power of this, and the airplane experiences a constant horizontal resistance force of 25,000 newtons. Okay, so immediately I'm thinking of that power formula. Power equals force times velocity. You know, power also is the amount of work you do per unit time. Find the speed of the aeroplane. Okay, so the airplane's producing this constant power. The airplane experiences a constant horizontal resistance force. Find the speed of the airplane. An airplane is flying at a constant speed. The airplane is flying at a constant speed. The airplane's engine are producing a constant power of 5,500 kilowatts. Airplane experiences constant horizontal resistance. Find the speed of the airplane. Isn't this just velocity equals power over the resistance force? So it would just be 5,500 times 1,000 divided by 25,000. Am I crazy? Am I crazy? Isn't it just that? It seems so easy. I guess it's just that. Yeah, because this is the resistance force that it's overcoming, so it's the driving force it's overcoming, and this is the power the engine's producing. So I guess velocity just equals 55. I don't understand why that's 2 marks. Okay, so this K means 1,000 divided by 25,000, which gives you 220 meters per second. That seems surprisingly easy. So I might have to see after I've done this question whether I got that wrong or not. Okay, but let's just do the rest of the question. Okay, the airplane then ascends 300 meters in 50 seconds while maintaining the same speed. The resistance force is no longer constant. Okay, the work done against the resistance force in ascending the 300 meters is this. The mass of the plane is that. Find the average power. Okay, so I did a whole video. It's called the work energy video. And to calculate these kind of more complicated situations, you substitute into this equation the change in K, the change in kinetic energy equals the sum of the work done. So all the sum of the work done as it's going through this motion. And so the airplane ascends 300 meters. So remember, work done is force times displacement. And so what do we have? The resistive force is no longer constant. and the work done against the resistive force in ascending 300 meters. Okay, so what are the work dones we have here? The work done, we have the work done by the plane. So the work done by the plane minus the work done to overcome the resistive force. And that's it. The airplane ascends 300 meters in 50 seconds while maintaining the same speed. The resistive force is no longer constant. The work done against the resistive force in ascending the 300 meters is 27,000. The mass of the airplane is this. Find the average power. Find the average power. I guess you'd also have the work done to overcome gravity. Right? Yeah. Okay, so this would be 0. So the change in kinetic energy is 0 because it ascends while maintaining the same speed. Because the change in kinetic energy, it would be half m change in v squared. If you don't know where I got this equation from, just look at my work energy equation, work energy video. So the work done by the plane equals to the work done by the resistant force plus the work done by gravity. The work done by gravity, the resistive force is just going to be is this. So 27, what's that? Just 27,123 times 1,000. It's 1, 2, 3, 4, 5, 6, 7, 8. So this is 2.7 times 10 to the 8 joules, plus the work done by gravity, like to overcome gravity, will be mg, the force, weight, times the displacement. And it's ascending 300 meters. So it's ascending 300 meters. So 300 meters, it's ascending 300 meters. So the displacement here will be 300. So our S here will be 300. So this is force, our force times displacement. The force in this one is mg, and this is 300. So mg is just 60,000 times 10 times 300. Okay, and we're trying to find the power. So this thing here, because power equals the work done time, so the average power will be this thing, whatever this thing is, divided by the time. Okay, so this is this. So 60,000 is 10 times 300. You know, I'm doing this for the first time. Like, if you want me to prepare and go through it like most teachers would probably do, I'll do it. But I'm showing you like me figuring it out as I go. I thought that might be like kind of useful. 1, 2, 3, 4, 5, 6, 7, 8. So this is 4. This is equal to 4.5 times 10 to the 8 seconds. No, not seconds. Sorry, joules. Okay, so therefore the power, the average power, will equal to this, the work done by the plane, divided by the time, which is 50 seconds. So it's ascending. So this thing, 8 divided by 50, which gives us 9 million. So this gives us 9 million watts, or if you want in kilowatts like they have, average power would be 9,000 kilowatts. Okay. You just tell me if you want me to prepare for these things, or you want me to just go through it like this. So you're seeing that, you know, like everyone's struggling, like it's not easy for everyone. Anyway, I also haven't done any of this material in ages. I assume when I do more of it, it'll be a lot easier. But, okay. Okay, so that makes sense, right? So this thing here is like the work energy equation. And by using this thing, I can see how the energy is moving during this ascension of the plane. And by doing that, I find the work done by the plane. And if I find the work done by the plane, I can find the average power exerted by this engine throughout that 50 seconds, which is this. Okay, so let's check that. Let's go to my Mac screen. Where's it? Here. Okay, so the first one was 220, which we got. Okay, 2 marks. And the next one was 9,000 kilowatts. Okay, cool, 9,000 kilowatts. Okay, so we got both of those. Go back to the iPad. Okay, so that's right as well. Okay. 4. I have a video on this as well. Okay, how many questions are in this thing? 5, 6, 7. Okay. Okay, so this is the Pulley thing. So 2 particles. So describing this thing, both start. The string part fixed pulley hangs vertically, initially at height x to the ground. The system is released from rest. Find the tension in the string and the accelerator. Okay, so this is you just resolve this. So the tension acts up because it's pulling it down in both cases. So the tension acts up from both masses. You have the weight of B here, and the weight of A here. And all you do to figure this stuff out is you resolve the forces around each mass. So for mass A, the sum of all the forces will equal to the mass of A times the acceleration of A. We're looking for the acceleration and tension. So the sum of the forces here, well, the tension is acting up, so you got the tension. You also got to think of how this system is going to be moving. I mean, because this has no friction, this system will be accelerating like this way. Right? It will accelerate up this way and it will accelerate down this way. Because this thing weighs more than this thing. So tension is tension minus WA equals the mass of A times the acceleration. Okay? Right. Seems all good to me. Okay, so we get, well, this is our weight is just weight equals mass times gravity. So mass is 0.3 times gravity, which is 10. Gravity is 10 meters per second squared. So this is going to be 3. So T minus 3 equals to 0.3A. So that's one equation. And for B, we do the same thing. The sum of the forces about B will equal to the mass of B times the acceleration of B. But in this case, because it's moving up, I guess that doesn't really matter. Does that matter? I guess it wouldn't matter. I don't really think you'd have to think about direction yet. No. Okay, so T, so you get here T. Well, it's moving up. I guess you would have to think about the direction. Okay, so if I'm being clear here, because we've noticed that this thing is going to be moving like this counterclockwise, that means that in fact that this weight is greater than this tension. And so this should actually be, if I'm being super clear, this should actually be the weight of A minus T equals MA. Because I'm assuming A is a positive. A is going to be positive. Yeah, like the direction is positive. So you have to care about the direction. Because the weight, because it's moving this way, that means this weight force is greater than the tension force. So, this is, it's the same thing. So it'll be 3 minus T equals 0.3A. So that's one equation. It's basically the same thing. You just basically switch the sign. And for this case, you'd have WB is going to be less than the tension. So you get the tension is positive minus WB equals MBA. And this thing equals 2. You get T minus WB is 0.1 times 10, which is 1, equals to 0.1A. Okay, so I guess you could just substitute anything you want here. So you could do, if you take this over, you get T equals to 0.1A plus 1. And so if you substitute this, so you substitute equation 2 into equation 1, you will get 3 minus this 0.1A plus 1 equals 0.3A. And that is going to give you 3 minus 0.1A minus 1 equals 0.3A. 3 minus 1 is 2, so it's 2. And take this over, so you get 2 equals to 0.4A. So A equals 2 divided by 0.4, which is 5 meters per second. 5 meters per second squared. So that's your A. I should do it in red. That's your A, and therefore, so you substitute that into, I don't know, anything. Substitute into 2. So you substitute this into 2. You get T equals to 0.1 times 5. Substituting into here, plus 1, which equals to what? 1.5 newtons. So T equals to 1.5 newtons. Okay. During the subsequent motion, B does not reach the pulley. When A reaches the ground, it comes to rest. Given the greatest height of B above the ground is 1.2, meters, find the value of X. Okay. Okay, so let's just look at the motion for B here. So for B, so it kind of like, so greatest height, so it kind of goes like this, right? It moves up to like here when this thing, so travels X, and this thing has hit the ground. So this thing has hit the ground, and then it kind of travels in free fall, like without the effect of the string anymore, to its highest point. It's not enough space, but it's to its highest point here, where this thing is now, this is 1.2 meters above the ground. So this is the pulley. Sorry for the bad drawing. So it like drops down, hits the thing, and then falls up to the highest point. So in B, so in that first bit of motion, we get, so those equations, look at those equations again. So we get equations. Okay, so we get, so our initial here, U is 0. Our final, we don't know. Our acceleration we know because we got it here. Acceleration will be 5 meters per second squared. I'm just trying to find equations for X at the moment. And we've moved X, distance X from here to here. This is our B. That's the same one there. Oh, this is our A. Wait, what does it say? B does not reach the pulley. B does not reach the pulley. Okay, I guess it's the other way around. Well, it doesn't matter. It's the same thing. I'll just redraw it. This is what I'm saying. Okay, you've got A here and B here. I just read it wrong. A here and B here. So your B, so as this thing, so as A drops to the ground, so here, as A drops to the ground, moves X, and then B will also move X up, because it's on a pulley. here. Move x up. This is your B. This is B. This is A. And then once it's here, it will go into a kind of free fall, moving up to its highest point at 1.2 meters. Okay, so what do I have? So v squared plus u squared. I don't know v. Do I have anything here? Distance. I'm not feeling too good today, boys and girls. I guess we could just do it in terms of v squared. Just looking if we have any equation. So we have this equation here, plus 2as. So v squared equals to 0 squared plus 2 times 5x. So therefore we get v squared equals to 10x. So we have one equation in terms of x. But I guess in the second point of motion, the v squared now is u. So in this part, so once it's hit the floor, the ball is now going up at this speed. And so it's initial, so this is like the first stage of B, and the second stage of the motion of B, I guess we have, the initial will be this thing. So it's our V here. This is confusing. And then our final of V is 0, because at the highest point it's not moving, right? So it goes like a parabola, it's a trajectory, it goes up and it's not moving. And in that part, our acceleration is minus g, or minus 10 meters per second squared. And the distance traveled will be this distance here will be this 1.2 minus 2x, because it's x as well. So 2x. Does that make any sense? So 1.2 minus 2x. Then we can find another equation, so we can do the same thing. We can say v squared, so plug into the same equation, v squared. I've just split it up into two segments of this motion. V squared, maybe I should have prepared so I could better explain it. Minus 10 times 1.2 minus 2x. So this gives us v squared, okay, equals to, no, our u is v. Okay, sorry. Let's just write that out so I'm being clear. They have two v's here, which is probably confusing. Okay, so our v squared plus u equals u squared plus 2as. So the v squared is 0 squared equals u, which is our v squared here, plus 2as, and that's 2 minus 10, and then 1.2 minus 2x. So this is going to be, we get v squared equals to, what is this? Take this, it'll be 20 of 1.2 minus 2x. So now we have another equation for v. Okay, so we can, so 20, so this is what? 12, 24 minus 40x. So therefore, if we equate these two things together, we get 10x equals 24 minus 40x. So this gives us 20, this gives us 50x equals 24. So x equals to 24 divided by 50. So 0.48 meters. Okay. You understand what I've done there? I've just said, okay, this first point as the point when A reaches the bottom, we've looked at that and found an equation here. Then once A has reached the bottom, now this object B is no longer affected by the string and is moving in free fall. So that's why we've used this as our acceleration. And then we found another equation for V, and then I've equated them together to find X. I should check that that's right first. Okay, where's my, oh, please tell me. Okay, Mac screen. Okay, where are we at? Okay, we've got the first one. We should check first. Okay. 5. Correct. And 1.5. Okay. And then we have 0.4. Okay, so that's correct as well. Cool. Okay, that's right. Back to iPad. Okay. Let's keep going. Three particles, P, Q, and R of masses that are at a rest in a straight line on a smooth horizontal plane. The distance from P to Q is 3 meters. Q is 3 meters. Okay. P is projected towards, so this is going to be a momentum question. 3 meters per second. So P is at 3 meters per second. And P, after P and Q collide, P continues to move in the same direction. Okay, so you have P moving at 3 meters per second. And then after they collide or whatever, this thing moves at, P moves at 1.5 meters per second. And this thing moves at, well, we don't know, they don't tell us that, right? Find the speed of Q, oh no, here we go. Okay, so find the speed of Q after the collision. Okay, so the initial momentum equals the final momentum, okay? Okay? Momentum is conserved. And momentum is equal to mass times velocity. So the initial momentum here of this system, well, this thing is at rest, so this have no momentum, so it'll just be P. So this initial momentum here is going to be the mass of P times the initial velocity of P, which is, just make sure P is correct, 3 meters per second. So this is going to be 0.6 times 3. 0.6 times 3. Yeah, I put that in my calculator. What? That's 1.8. Okay, and so the final momentum is going to be the mass of P times the velocity of P plus the mass of Q, because now there's two things moving together, well, they're both moving, times the velocity of Q. Okay, and what is that? Well, the mass of P is 0.6. 0.6 times the velocity of P, which they said is 1.5 after that collision. 1.5 plus the mass of Q, 0.8 plus VQ, which we're trying to find. So as this thing is conserved, so you can say as PI equals PF, therefore we get this, so 0.6 times 1.5. So this thing equals 0.9 plus 0.8 VQ. So therefore we get 1.8 equals to 0.9 plus 0.8 VQ. Okay, so you take that over, you get 0.8 VQ equals to 0.9. Take that over. 1.8 minus 0.9 is 0. Divided by 0.8 gives us what? Momentum is, 0.9, 0.6 times 1.5. So, the mass is not that. God, this is so bad, I'm sorry. I'm probably going to prepare next time. This is 0.4. Sorry, I put in the wrong mass. I was looking at that one. I'm not used to speaking and doing work. It's been a while. Anyway, so this is 0.4. So this is 0.4. This is 0.4. Okay, so 0.9 divided by 0.4. So VQ equals to 2.25 meters per second. Okay. In the subsequent collision between Q and R, these particles coalesce. Find the speed combined of the combined particle after the collision. Okay, so we have a I can do it like that. Particle moving at this speed, we could call it 2.25 meters per second. And we have this one at rest. Then R, and then they collide, their collision together. Find the speed, so we want to know what V of what QR is. QR. What is that? Which we can definitely do. So the initial, so P initial equals P final. So the initial is this, which is our Q. So MQ VQ UQ equals to the final, which will be MQ plus MP, MR equals to QR. So then the velocity together. So this thing here, so MQ UQ is this, which is 0.4 times 2.25. 0.4 times 2.25 equals to the sum of the masses of those two things. 0.4 plus 0.8 is 1.2 VQR. Okay, so then you can find VQR. So when they come together, basically. So we get 0.4 times 2.25 divided by 1.2. 0.75 meters per second. Okay. Find the time it takes from when P is initially projected until the instant at which P collides with a combined particle. Oh God. Okay. So we have a lot going on here. So it's projected, it strikes this thing here, it then moves here. Maybe we should write all these things down to make it easier for us. Okay, so it's projected at speed. It's projected at the speed 3 meters per second. So 3 meters per second. It then collides here. Collides with Q. This is P. And then collides with Q. This thing is 3. This is 3 meters. Collides with Q. Then P moves at 1.5 meters per second. And now we know what Q moves at 2.25. 2.25 meters per second. This is Q. And then Q collides here with R, Q and R, and they move together at 0.75 meters per second. So that's basically what's going on. And it wants to know when this, so it collides and then it starts moving. When does it hit this thing? That's what it wants to know. And this between here and here is 3 meters as well. Okay, so what does it say? The time. It's going to need the time. So we're going to have to find what? We're going to need the time to collide here. So this T1 here. We're going to need the time. Then we're going to need the time that P has moved. The time that P has moved. So T2 will be the time P has moved at the point in which P and Q collide. And then the next time will be the final time, let's call it T3, is when P then recollides with Q and R. So you got P, it hits Q, and then it moves at 1.5 meters per second, and then Q hits R, and that moves at 0. Q and R move at 0.75 meters per second, and then P, because it's moving 2 times the speed of Q, will eventually hit Q and R. This is pretty hard, actually. It will eventually hit Q and R, and then that is the total time. So when the start of P to when it collides with the combined particle. So the total time will be this T1 plus T2 plus T3. So we need to find these things individually. The first T1 is very easy. T1 will just be, we have 3 meters. We know velocity equals distance over time. So time equals, so this T1 will equal to our distance over our velocity. We're moving at 3 meters per second. So when we collide with Q, this is just going to be 3 divided by the velocity, which is 3. So this is 1 second. So, okay, so that's T1. That was easy. T2, I've said this, T2 is that time. So for T2, we don't actually need T3. We don't need T2. We need when it collides with this, and then the next one is when T3 is when it re-collides with this. So it's 2 times. But we're going to need this time because we're going to need the distance to help us find this new. I guess you could look at it like that. T2 gives us when Q collides with P. And we want to see how far this thing has moved. Okay, I remember what I said. Okay, T2. So T2 is the time of how far this thing has moved, and this will help us find T3. Is that making sense? Am I explaining that well? So this first time, T1, is when P hits Q, and now we're finding this time when Q hits R and seeing how far P has moved. So what is the T2? Let's just find T2 for now, because that's also a time involved, because it will show us how far it's moved and how close, then it will help us find T3. Okay, yeah, this is going to be right. Okay, so Q is moving at 2.25 meters per second, and it moves 3 meters to hit here. So T2 is going to be distance over velocity, which is 2.25 divided by 3, which is... Oh no, distance is 3, sorry. Or velocity is 2, sorry. 3 divided by 2.25. Okay, so that is 4 over 3 seconds. Okay, so this thing here is going to help us because it will tell us that, okay, so P at this point is moving at 1.5 meters per second and is moving for 4 over 3 seconds. So where is it at that time? So where's P after that? We can find that very easily. We can say, well, like velocity, so the distance will be VT. So it'll just be 1.5 times 4 over 3, which gives answer times 1.5. So 2 meters. So it's moved 2 meters. So this is P. So when Q collides with R here, P is here. And this thing from the starting point was 3 meters. Okay, so the distance here between this and this is 1 meter. So we have got to this point in P's motion where it's 1 meter away, and Q and R have just collided and begun to move away from each other, move with each other at 0.5 meters per second. Okay, and this is moving at 1.5 meters per second. Okay, so we have a scenario to find T3. We have P, which is moving at 1.5 meters per second, and we have Q and R, which is moving at 0.75 meters per second. And the distance between them is 1 meter, because we found that here. Okay, and so we want to know at what time will this thing hit this thing if they're moving like this? Well, we basically want to know when the displacement of P, or the distance of P, equals to, so when they hit, it'll equal to the distance. So if you think about it, like we want to know the point. So when they're these two, So this is when they're the same. When the distance were the same, because that's when they're going to hit. So that distance here, this is SP, and this thing will be the displacement of this object, QR, plus 1. Because you have 1 meter extra here. So when do these two lines equal each other? It's when this distance or displacement of this object plus 1 equals the displacement of this object. Right? And we can find that. We got some formulas here we could definitely use. Do we even need? Yeah, there's no acceleration. So what? I mean, this would just be what? Yeah, this is easy. Okay, so we have so distance equals velocity times time. So this is the velocity. So the initial velocity of P, which is that, times the time, which we don't know, which is going to be our T3, equals to this, which is 0.7. Oh, okay. The initial velocity of QR, maybe this notation isn't right, times T, the thing that we want, this is our T3, plus 1. So we can find it. So we got this thing, which is 1.5 T, equals to 0.75 T plus 1. Take that over, we get 0.75 T equals to 1. So T equals to 1 divided by that, so T3. So 0.75 divided by, or 1 divided by 0.75. This equals to 4/3 seconds. So this means, this T3, this means after P is at that point which we found when these two things collided, and where P is at when these two things collided, after that, how long does it take for P to collide with Q and R? Is this. So the total time will be 1 plus 4/3 plus 4/3. T1 plus T2 plus T3. That's actually quite a hard question. Plus 4/3 plus 4/3. Should we check if I got it right? 3 times 2 plus 1. So this is 3.67 seconds. So the total time is 3.67 seconds. What's so difficult about that? I mean, I'm doing it for the first time, but what's so difficult about that is like, it's just a lot going on. You have to kind of visualize it a lot. All right, let's just check it out. Okay, max screen. This whole question. Okay, 2.25A. Yes, I got that. 0.75. Yes, I got that. And the last one. See what? Look, maybe they didn't even do it how I did it. Is the last one is 11/3. Which should be what I got. 11 divided by 3. Yeah, 3.67. Okay, so I got them all right. Okay, let's go back to that iPad. Okay. Tick. 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 Okay. Right. Yeah, I guess like what's so difficult about it? I mean, that's difficult. That one is actually quite difficult. You have to kind of visualize what's going on. And I would always recommend with these more complicated situations where you've got things colliding, recolliding, like you should just split it up as into as smaller segments as you can deal with. Looking at the whole thing overall is quite difficult, but looking at like each individual segment like I did is easier to do. Like the hard part of that is identifying that I needed to find that distance, because that distance for that kind of T2, which I was looking at, that distance would have given me, helped me find this last T3 where P and collides with Q and R the first time. Anyway. Okay, 6. I think we got 2 more. 6, 7. and then finished. All right. Wonder how long this has been. Okay, this is the incline. I've got videos and all this stuff. I mean, I did it ages ago, but the fact that I can still do this is indicative of how good they are. A block of mass 12 kgs is placed on a rough plane incline. Okay, they're just explaining this basically. Okay, I remember the friction is mu times the normal force which acts up due to the weight. I'm just noting that. Is given this and this, find the time it takes for the block to move down the plane from rest. I'm just going to start resolving things immediately. So we've got the weight of the block, and then we've got this here. So this is Wx and Wy. This is, Wy will be the normal force. This is alpha. So opposite. So sine alpha equals to Wx over W. So therefore, Wx equals W sine alpha, and Wy will equal W cos alpha. I'm just doing that straight away. Okay, find the time for the block to move 2 meters down the plane from rest. Okay, so even with this force, when you release it, it's starting to move down. If it's starting to move down, that means that the frictional force acts in this direction. Let's call it F mu. So the frictional force acts in this direction. And direction is important for this stuff. So we have I guess this is doing the sum of all the forces again. Find the time it takes for the block to move 2 meters down the plane from rest. It's 6 marks. Okay, so we have we want to sum up all these forces. We want to sum up all these forces. And this will equal to mass times the acceleration of the block. So we can find the acceleration of the block. If we find the acceleration of the block, we can probably find, we can find the final velocity. Oh no, we can find the time with those equations that we have. Yes. Okay, so summing up all this stuff, we get, so the work done, so we'll take up the slope as positive, or we could take it as negative. It doesn't matter, as long as they're different. So this would be Wx minus, I guess we take x. We'll take up the slope as positive. So x plus f of mu minus Wx. And this thing is x plus f of mu is mu, normal force is this Wy minus Wx. Okay, so we get, okay, so let's write that out even further. So x plus mu, Wy is mu, and W is the weight, so W is equal to mg. So this is mg cos alpha minus mg sine alpha, Okay, so this will equal to the mass times the acceleration of this block. Okay, so this thing will be, I guess we can just plug everything in, right? We have this, we have this, have this. Okay, we're finding the acceleration, because we find the acceleration, we can find the time. Okay, so this is 20 plus mu is 0.15. Mass times gravity is just 12 times 10, which is 120 cos alpha they have here. minus 120 sine alpha. And this thing gives, I would first work this thing out. So I'll work out alpha. So alpha equals shift tan of 0.5. So this gives a number, a long number, gives 26.565 degrees. So, and I'm going to plug that number directly into here. So we get 0.15 times 120 cos of this answer, which I just got here, minus 120 sine of this answer. Gives us that plus 20. This gives minus 17.565 if you plug that in. And then this mass is 12a. So then we get acceleration of this object divided by 12 is minus 1.463, which is good, is negative because it should be going down. Okay, so now that we have the acceleration, we can find this thing. So it's moved a distance of 2 meters. Our displacement, it's accelerating. We're going to use that positive direction as down at 1.463. I'm going to keep this number here on my thing. And we have its initial velocity, which is u equals 0. Do we have anything else? The time taken. Okay, so we can use this. We can use this equation. So on your formula sheet, you have ut plus a half at squared. So we have this, we have this, we have this, so then we can find time. So 2 equals, this is 0 times t, because u is 0 because it starts at rest, plus a half a, which is this 1.463 t squared. So times -1 divided by 2, you get 2, so 2 divided by answer, so you get t squared equals to 2.7325 and so t equals the time would be 1.65 seconds. 0.65 seconds. Okay, so you just resolve the forces and yeah. Okay, B, let's keep going. It is given that instead that this, when x is 10, the block is on the point of moving down the plane. Find the value of mu and the value of x for when the block is moving up the plane. Okay, so when it's moving, down, about to move down, it's just about to move down, the sum of these forces that we calculated here, it's just, so it's not accelerating, it's just about, so it's not accelerating yet. The sum of these forces are going to equal 0. But the sum of these forces are, as it's just about to move down, will be just about to move down. So the frictional force is acting up, it's just about to move down, and the x is acting up, and then wx is acting down. So it's just going to be the same, basically the same thing, but this thing's going to be 0. So it's going to be x minus x plus mu mg cos theta minus mg sine alpha. So this, therefore we get x, so x plus, I'm going to factor out an mg to make it look easier, alpha plus sine alpha equals 0. And we're doing all this so we can find x. Oh no, we can find this thing. Because at x, it's about to move down. So we know our x. So let's rearrange from mu. So actually, I probably shouldn't keep that. So we get x plus mg mu cos alpha minus mg sine alpha equals 0. I hope it's clear what I've done here. I've just done, this is the same thing. It's the same force, resolving the same forces here. But in this case, it's not moving yet. So it's not accelerating yet. So it's so MA, our MA here, this thing equals MA. This thing, our A is 0. So this whole thing equals 0. Okay, so then we're going to rearrange for mu. So we get mg mu cos alpha equals to mg sine alpha plus minus x. Take that over. Divide by mg sine mg cos alpha. So we have an equation for mu. We have all these things. So therefore mu equals to mg is just 120. This thing is 12 kilograms. Sine of alpha, which we can plug in, minus 10 in this scenario is 10 divided by 120 cos alpha. Okay, if you put that stuff in, so again we have the shift tan of 0.5. I'm just plugging in this exactly. So I'll just show you what I'm doing. So 120 sine of tan inverse of 0.5 minus 10 over 120 cos of tan inverse 0.5. So I can keep it an exact value. So sine answer times 120 minus 10 divided by 120 times cos of shift tan 0.5 gives us 0.4068 ... So we have our mu. So that's our mu. I guess we'll round it. So mu equals 0.4067. I don't know how many significant figures they require in this paper. Okay. Find the value of mu and the value of x for which, because this stays the same. So it's to do with the surface. So this is going to be the same value always. So we just found out what that value is because it's no longer this. And then the value of x for which the block is on the point of moving up the plane. Okay, so the only difference here, they're not giving us enough space, but as it's moving up the plane, the only difference here is the sum of all the forces will equal 0 again because it's not accelerating yet. The sum of all the forces is going to be different because, in fact, as it's moving up the plane, this frictional force now will be acting down. And that does make a difference because this thing will be now, you've got x is positive, acting up, minus these two things. So that's the difference. So you got x minus wx minus the frictional force. So in this one here, the frictional force is positive, but in this one, the frictional force is negative because it's about to move up. That means that the friction will be pushing it back down. Okay, and this thing equals 0. So it's the same thing. So you get x minus wx is mg, what's that, wx? Wx is mg sine theta is mg sine alpha minus rf mu is mu mg cos alpha. Mu mg cos alpha 0. So therefore x equals to mg, we can factor it out, sine alpha plus mu cos alpha. Okay, so we plug all those things in, we get this cos times, so we're using this result because this is constant no matter if it's moving up or down, times cos of shift tan of 0.5. So I guess I'll make it clear. So this is 12 times 10. Do you want me to write everything out? Is that what you guys want? times tan inverse of 0.5 plus this thing 0.407 times cos of tan inverse of 0.5. Okay, and that will give us an x value. Okay. Times answer. Okay, plus sine of shift tan 0.5 times 120. 97.3. 97.3. Okay. Alright, let's check. Is that finished? Okay, no, one more. Okay, let's check those. Max screen. Okay, so this is question 6. So 1.65 for the first one, correct. And 407. Okay, so they do round to 3 significant figures. 407 and 97.3. Okay, correct. And make sure I go back to my iPad. Okay, so these are correct. Correct. That one was quite a lot of marks, I think. I have a really good video on this. If you go watch my video on this exact question, these will become a lot easier. Okay, last one. How are we doing? Stuff is tiring, huh? 1, 2. Oh, it's another really big one. A particle moves in a straight line with the velocity v of the particle at t seconds after leaving a fixed point O is given by this. K and v are constants. The acceleration of the particle at t equals 1 is 42 meters per second. The displacement particle O is 2 equals 1 is 93. Show that K and P are this. Okay, so what do we have? We have V equals A of 20 plus PT minus 6t squared. Okay, they say the acceleration of the particle at t equals 1 is this, and the displacement of the particle at t equals 1 is this. So if we find equations for displacement and acceleration, we can find 2 equations relating P and K, right? Yes, we can. Okay, so acceleration. So dv by dt, this is the acceleration, the rate of change of velocity, is equal to this thing differentiated in terms of t. So this would be k of, well, it's just d by dt. Do you want me to write it all out? I'm not going to write it. Okay, times, so this thing, so it'd be k of 20 is a constant, so 0 plus this thing becomes p plus minus times down be minus 12t. So this thing equals k of p minus 12t. Okay, so therefore if we want, so dv by dt at the point t equals 1 is equal to 42 meters per second squared. So therefore we get an equation, k p minus 12t equals to 42. So this is our first equation, which will be important. And then with the displacement one, so, v is dx by dt equals to k of 20 plus pt minus 6t squared. If we integrate both sides, we get the displacement, which is x, which will be, and it says the displacement of the particle from 0 at t equals 1 is 93. So this thing evaluated from 0 to 1, so at t equals 1, will give us the displacement of 93. So this thing, so we can take the k out, because it's a constant. We take the k out and we get, so this is 20t plus pt squared over 2 minus 6t cubed over 3 between 1 and 0. That is just 2t cubed. Okay, so we just plug those things in. So we get equal to k of 1 will be 20 of 20 plus 1 squared is 1, so p over 2 minus 2. Minus 0 is a 0, 0, 0, so this thing will be 0. So this gives us x equals to, so for this thing, this will be 93, right? Because this thing evaluated between those two limits is 93. So 93 equals to k times 20 minus 2 is 18 plus p over 2. Okay, so that's a second equation with p and k. So now we can just find them out by substituting one into the other. Correct? Correct. Could just divide them by each other. That will get rid of a k. So 1 divided by 2 will give us, we'll write it out. So k, we get k of 18 plus p over 2 over k. Oh no, sorry. Get 1, which is this, k p minus 12t, k of p minus 12t, and 18 plus p over 2. So dividing that, and then we're dividing 42 by 93. So the k's will cancel, and we'll get p minus 12t equals to 42. So 42 over 93, which is 14 over 31. 14 over 31 times 18 plus, no, dividing, we're timesing through, okay, so this is 14 over 31 times 18 plus p over 2. Okay, and then we can just expand it in. So we get p minus 12, wait, was there a t here? There's no t here. Sorry, I substituted in 1 here. There's no t there. I just noticed that. My bad. Okay, so there's no t. Of course, there's no t because I substituted in 1. 1 for t. I just forgot to get rid of the t. Okay, so that's 12. That's 12 equals to times 18. This is 252 over 31 plus 18. This thing divided by 2 plus 7 over 31p. So 7 over 31, 1 minus that. So we get 24 over 31p equals to 252 over 31. 252 over 31 plus 12. What's that? This is not looking good. This might have to recheck this. Times 31 divided by 24. Oh, it is good. So we get p equals 26 if you rearrange that, which is what they wanted. Okay, cool. Still rusty, huh? And k, so if you want to just find k, you just plug it into one of these equations. So you plug it into here. So if you want k, so from 1 you get k equals to 42 over p minus 12. So 42 over p minus 12. So p is 26, so 26 minus 12 is 14. So it gives us 42. 42 over 14. Substituting in p, 26 minus. I don't know how much I have to write out to get what I'm doing. This is 42 over 14. So 40, hopefully that equals 3. It does. So therefore k equals 3. Cool, we don't need to check that answer because I proved it. So that's right. So k is 3 and p is 26. Cool, sweet. Okay, 6 marks. Jeez. Okay, and I guess this must be the last part, right? And then we're finished. I'm going to take a break. Okay, find the distance moved by the particle between the time at which acceleration is 0 and the time which its velocity is 0. Okay, let's just write out these equations. So our acceleration equals to kp minus 12t. So k a of p minus 12t, and our velocity equals to k20 plus pt, k20 plus pt minus 6t squared. Okay, we know what these things are, so we'll just make this look better. So 3 times 26 minus 12t, and this thing equals 3 times 20 plus 26t. I'm just subbing in these values, minus 6t squared. So this thing equals to 3 times 26, so 78 minus 3 times 12, 36t, and this thing equals 60 plus 26 times 3, 78t, minus 3 times 6, 18t squared. Okay, I'm just getting the equations for acceleration and velocity. Find the distance moved by the particle between the time at which its acceleration is 0 and the time distance moved and the time which its velocity is 0. Okay, so let's find out when those times are. So when its acceleration, when the acceleration is 0, we get this thing equals 0. So we get 0 equals 78 minus 36t. So therefore we get 36t equals 78. So therefore t equals 78 divided by 36, which is 13 over 6 seconds. And for the velocity, when this thing equals 0, and when the velocity equals 0, we get 0 equals 60 plus 78t minus 18t squared. Divide, well, if I divide everything by 2, let's take everything over. So 18t squared minus 78t minus 60 equals 0. I'm going to divide everything by 2. We get 9t squared minus 78 divided by 2. 39 minus 30 equals 0. Can I make it any smaller? 39 divided by 3 is 13. Okay, so divide by 3, so we get 3t squared minus 13t minus 10 equals 0. Okay, so t will equal to minus b, which is 13 plus or minus the square root of 13 squared, so 169 minus 4 times 3 times minus 10 over 2 times 3. So it's going to be 13 plus or minus 4 times 3 times 10 plus 169, it's minus, square root that, goes to 17 over 6. So it can't be 13 minus 17 because that will give you negative time, so it's not possible. So we get t equals to 13 plus 17 divided by 6 is 5 seconds. Okay, here's our first one. So this one. Okay, so the distance moved between those two times. Okay, so our displacement we have already up here is this. X equals this thing. So what is it? K 20t 20t. I guess I just have to evaluate. 20t, I'm just making sure this thing's right. that's cubed. Okay, so our x is going to be this thing here, but not evaluated between these limits, because that's this thing integrated. So you get k of 20t plus a half pt squared, 20t plus a half pt squared minus 2t cubed, minus 2t cubed. Okay, so our p was 26, so half of 26 is 13, so this thing becomes 13, and k is 3. So this thing evaluated, so we want the distance, right? That's what I was, find the distance moved between these two things, 13 divided by 6. So we want the distance between 5 and 13 over 6. So let's do that. So it's 3 times, okay, so 5 would be 25 plus 13 5 squared minus 2 5 cubed. That minus 20 13 over 6 plus 13 over 6 squared minus 2 13 over 6 cubed. Okay, so just gonna plug all this crap in. Okay, so 20 times 5 is 100. So this is 100. 5 squared times 13 is plus 325 minus 5 cubed times 2 minus 250 minus this thing, which is 13 over 6 times 20. Just going to keep these in fractions. 130 over 3 plus 13 to the 13 over 6 squared times 13. Whoa, 2197 over 36 minus 13 over 6 to the power of 3. It's going to be a big number. Times 2. This is 2197 over 108. Okay, so what is this thing? So this times -1 plus 2197 36 plus 130 over 3. So this entire thing is 4447 over 54. 100 plus 325. I'm not feeling good about this. This is 175 minus that times 3. 175. So 4447 over 54. 175 minus answer times 3. I got not feeling like this last part was correct. 13 over 6 to the power of 3. God, this arithmetic is so much. 2197 over 108. 13 over 6 squared times 13. 2197. This thing minus 2197 over 108 plus 130 over 3. No, not plus, minus. Oh my God, minus 13 plus 130 over 3. Four, 537. Okay, 175. 4537 over 54. 175 minus answer times 3. Yeah, I'm just gonna go with this. I think this is 272.5 I guess you say 273. 273 meters? Did they give anything? Yeah, meters. Okay, so the answer I got was X. I'll check this now. 273 meters. Okay. Let's go to my Mac screen. And 273 meters. Boom. Oh. Okay. Okay, I guess that's it. I mean, wasn't great. I mean, I got what? Everything. I think I made one little mistake somewhere, but I got all this right. So I think we're fine. Hopefully that was helpful. If you want me to actually prepare, I should probably prepare more. I just want to explain as I'm going and sort of practice my moment to moment explanation of these things. I see a lot of teachers online, like they're so prepared in everything they do. It's kind of artificial. I mean, I'm showing you exactly what I'm going through when I'm working through these problems. I'm thinking about them. I'm having ups, I'm having downs, I'm confused, I'm like figuring it out, working it out, developing like my skills in this paper or whatever. And this is exactly what you'd be going through. It's not some artificially prepared perfect thing. No, it's like it's a war, man. You're out here, you're trying to figure out how to do this crap, you know? And a lot of it, I mean, even some of these questions, I mean, they're not easy. I mean, some of these questions are quite difficult, and I can see a lot of people would get them wrong. And so you shouldn't feel bad about getting them wrong. I even made some little mistakes here. To be fair to me, I haven't done this stuff in a while, but like it's difficult stuff and it's not easy to do. And sometimes online you get this presentation of perfection, but in reality that's not actually the case. And so yeah, anyway, I hope everyone is good. This is the second video I've done now, and I will continue to move through all these things. I'll upload all these papers, and I'll even probably start to do another course on YouTube. And then I'm also going to start uploading papers and new stuff on Patreon as well. And I want to do more things than just this stuff. I have some pretty cool ideas, but it just takes a lot of effort and a lot of work to actually materialize those ideas digitally online. I'm working on a lot of other things as well. Just on the side, I have a lot of things that I'm working on in terms of physics and mathematics, which I'm interested to also share with people. Anyway, I hope you are all very good. I hope your exam studies are going well. And I will see you when I next see you. Goodbye.